Molecules must be able to move in and out of cells. Many molecules are too large to move across the plasma membrane, and the membrane has an ingenious solution to this problem. It can engulf large particles and liquids within its environment in a process known as endocytosis. Endocytosis occurs when large molecules or particles move towards the cell membrane. The cell membrane then moves inwards, forming a small indentation that traps the molecules. So you can see here that these orange spheres represent a substance that's moved towards this lipid bilayer here, which forms the cell membrane. That's caused the cell membrane to indent, which actually traps these substances in that area. The indentation then becomes a bubble, which is on the inside of the cell and has trapped all of those substances that were previously on the outside of the cell. That membrane finally forms a vesicle, which pinches off the cell membrane and moves into the cell. And this is how particles are actually imported from the outside the cell to the inside the cell through endocytosis. There's actually two main forms of endocytosis. There's pinocytosis and phagocytosis. In pinocytosis, the cell engulfs small amounts of fluids and dissolved substances. In phagocytosis, the cell captures and engulfs large particles. So this can be referred to as cells drinking and cells eating. Once a cell has engulfed either a fluid or a large particle, the vesicle that is formed actually fuses with a lysosome, and that lysosome releases enzymes into the vesicle that break up the molecules or particles. So an example of this is white blood cells. So this electron micrograph here from a scanning electron microscope is actually a white blood cell. And that white blood cell is actually engulfing a foreign body through the process of phagocytosis. So the opposite of this process is called exocytosis, and this is where large molecules and particles are transported out of the cell across the plasma membrane. And I remember this because I think of the EX as standing for the EX in exit, because this is what's occurring, is that substances are actually exiting out of the cell. In this process, a small membrane-bound vesicle, which is in the cytoplasm, moves towards the cell membrane. When it gets there, it actually fuses with the cell membrane and then finally releases the substances that were inside the vesicle out of the cell. So an example of that is when the tip of a neuron cell releases neurotransmitters which then stimulate or inhibit impulses in a neighboring neuron cell. So here is an example of two neighboring neuron cells or nerve cells that transmit the nerve impulses throughout your body. Now they don't quite touch one another, but they need to be able to transmit messages from one nervous cell to another in order to conduct electrical impulses in your nerve cells. And in fact, there's a small gap called the synaptic cleft between one of the neurons and the other neurons. And in order to bridge that gap, there are small synaptic vesicles in which are the chemical signals called neurotransmitters. And those neurotransmitters in the vesicle move towards the cell membrane, where they fuse with the membrane, release the neurotransmitter, which travels across the synaptic cleft and then moves on to the next neuron, where the signal can continue to be transmitted.